Thanks, Joe. I appreciate the introduction and thank you for the opportunity to present today. I'm excited to share some information with this group about the National Lakes Assessment. First, I want to acknowledge my co-authors, Morgan Mack, Garrett Stillings, Sarah Lehman, and John Healy. But really, you will hear throughout this presentation that this is a huge effort. We have so many state and tribal partners, and it's really our partnerships that make the National Lakes Assessment and the NARS program a success. So I want to thank all of them as well. And so I have kind of three major sections to the talk today. The first is going to give you the background and overview on the National Aquatic Resource Surveys and how NLA fits into that. The second component of this talk is going to present the NLA 2022 results with the Midwest Glacial Lake subpopulation results. So we were able to do some survey area specific analyses for this group. And then finally, I'd like to wrap up this talk with an overview of a lot of the tools that we have available. And I'm hoping kind of give you a few ideas of maybe some tools that might be applicable to the work that you all do. So starting with the background, EPA and states are charged with reporting on the condition of the nation's waters under the Clean Water Act. State monitoring strategies have been designed over the years to address the pressing state-specific or watershed-based initiatives. These initiatives are what are necessary to support those local management and regulatory actions. They do not, however, lend themselves to report on the condition of the nation's waters as a whole. So states have different priorities, they have different field collection methods and assessment methodologies, and this creates a big challenge for combining data sets and results to generate the national perspective. The National Aquatic Resource Surveys were developed in response to this national need. EPA, with our state and tribal partners, were asked to develop a national program that will support the growth and implementation of state and tribal water quality programs as we collaborate to produce a statistically valid assessment of the nation's waters. So with this program, when we're asked if water quality is getting better or worse, we hope we'll have a better response than the 1989 EPA administrator that said, I think so, but I can't prove it. So the National Aquatic Resource Surveys have three primary goals. The first is to assess biological and recreational condition and changes over time of the nation's waters using indicators of condition and stress. The second goal is to rank those stressors based on the relative associations between indicators of condition and indicators of stress. And the third is to build and enhance state and tribal monitoring and assessment capacity. So the NLA is one of 5 water resource types that are sampled on a 5-year rotating basis. The first NLA was conducted in 2007, and then the most recent survey was conducted in 2022. NLA and all the NARS surveys are based on a probabilistic study design, which means that sites are randomly selected from a defined target population and sampling frame. So for the NLA, the target population is lakes and reservoirs and ponds that are at least greater than 1 hectare, greater than 1 meter deep, and have greater than 0.1 hectare of open surface water. We exclude things like the Great Lakes, the Great Salt Lake, commercial treatment ponds, coastal and ephemeral lakes. The sampling frame is based on the lake polygon features in NHD plus high res. The design is stratified by state, which is super important that each state has some sites associated with it, as well as 4 lake size classes. We do have some separate funding to do a limited amount of targeted or hand-picked sampling. Often this is reference lake sampling. And we aim to sample 50% of sites that were sampled in the previous survey. The states and tribes receive funding to do 1,000 site visits. And our sampling consists of a single sampling event with a 10% revisit. So the core sampling of 1,000 visits equates to 904 lakes sampled for each survey with 96 revisits. The samples are collected through June through September for a defined index period. And at each lake, samples are collected from generally two different locations. There's the index site, which is either the deepest point in a natural lake or the center of a reservoir. The index site sampling includes in situ profile data, the water chemistry sample, in which we do chlorophyll A, nutrients, ions, and then we also do biological sampling of phytoplankton, zooplankton, and we've been collecting environmental DNA as well at our index site. Sampling also includes 10 randomly selected, evenly spaced littoral stations as well. And this is where physical habitat and benthic macroinvertebrate data are collected. The physical habitat data might be of interest to this group, includes observations and measurements of substrate, vegetation, depth, woody debris, human disturbance, as well as the littoral and shoreline riparian habitats. I already mentioned that we collect benthic macroinvertebrates there, but we also collected an Ecoregion sample and environmental DNA samples from the littoral sites as well. And there are a couple whole lake activities, and that's when we are collecting fish for fish tissue contamination, as well as just general observations of stressors around an individual lake. So the survey includes a combination of core indicators and research indicators. Core indicators are used in the national reports for assessing chemical, physical, and biological objectives of the Clean Water Act and the fishable, swimmable goals of the Act. Typically, these core indicators are implemented every survey cycle or maybe on a rotating basis of every 10 years if that's appropriate, and it makes it more cost effective. And then funding for the collection of these samples comes from Clean Water Act 106 monitoring initiatives. So these are selected to provide a holistic understanding of lake condition. So for example, to assess biological condition, the survey includes benthic macroinvertebrates, to give an understanding of the benthic littoral habitat condition. Zooplankton are representative of the open water. Phytoplankton and chlorophyll A provide a measure of lake productivity. But I also want to point out two new indicators under human health and recreation that were added in 2022. The Ecoregion sample, as well as fish tissue samples were collected in 2022 due to additional funding that we received from our partner office, the Office of Science and Technology. Consistent assessment benchmarks are also a key component of the NARS program, and there are two types of benchmarks that we use for NLA. The first are nationally consistent literature-defined benchmarks. When available, we use EPA's 3048 criteria for these benchmarks. This includes the benchmarks that we use for cyanotoxins, dissolved oxygen, and Ecoregion. We also use chlorophyll A, consistent chlorophyll A benchmarks when we're describing trophic state. The second type of benchmark the survey uses is regionally relevant NLA-defined benchmarks. And so these are developed from lakes that are identified as minimally disturbed or reference lakes. They're defined by fixed percentiles of the reference condition. Results for these indicators are typically categorized into a good, fair, or poor condition category, with the good to fair threshold at the 75th percentile of reference condition, and then the fair to poor threshold at the 95th percentile of reference condition. This approach is used for our biological, habitat, and nutrient indicators, since the expectations for these can vary quite drastically nationally. And I want to give a quick pitch here for the NARS reference site visualization tool, where you can explore the sites and data that have been identified as reference for NLA and all the NARS surveys. NLA has also supported a variety of research indicators over the years, some at the national level and others to address either state or regional priorities. Most recently in 2022, the survey collected environmental DNA samples to support the development of a fish indicator for the survey. We still have a lot of work to do on that one. We also analyzed water chemistry samples for dissolved nitrogen and dissolved phosphorus because of additional funding we received from EPA's Office of Science and Technology. who's responsible for numeric nutrient criteria development. So I just want to point out that the 2022 data set is unique, that it includes both total and dissolved nutrients, if that is something of interest to your group. So now I'm going to transition to the portion of the talk that focuses most on the most recent NLA. The survey results were published in August of this year, so not too long ago. Feel free to scan the QR code in the corner of the slide to view the report on your phone or tablet. And then when you're viewing on a mobile device, you can either scroll through the report or click on the little hamburger button in the top left corner of the screen to view and select the section of the report that is of most interest to you. It should open up a drop-down screen like you see here on the slide. In NLA 2022, the field season included the sampling of 981 probability lakes by 80 field crews. This map shows the distribution of the probabilistic sites in the 9 NARS ecoregions that are used to set the ecoregional benchmarks. And it's these 981 lakes that were used to represent the estimated 268,000 lakes in the survey target population. There were EPA regional crews that also sampled 153 hand-picked lakes. These were originally sampled in the 1970s as part of the National Eutrophication Survey, and data are still currently being worked up for that special study. But I mean, this is a huge amount of work that's completed during just that short index period from June through September. And there's no way we could ever do this without our state and tribal partners. I want to point out that the MGLP service area actually kind of goes into 4 different NARS ecoregions, including the upper Midwest, the temperate plains. There's just a tiny portion here in the northern plains, and then you get the western portion of the northern Appalachians also in your service area. And another cool component, I think, of the NARS survey is its ability to support sampling intensifications and enhancements. Just so you have an understanding of what we consider what these two things are here. An intensification is when the density of sites within the national target population is increased. And this might be done because a state is interested in calculating a reasonable population estimate for their area that would normally not have enough sites to have certainty in that estimate. Data collected from intensifications are typically included in the national estimates when we're calculating those for the national perspective, assuming that they collected data for all the indicators in the survey. An enhancement, on the other hand, is a complementary study that takes a lot of different forms. It could be an area expansion. You can increase the frequency of the sampling in an area. There might be a region that's working on modifying a new method or creating a new method or indicator. And then we have a number of research indicators as well. So in 2022, 4 states completed intensifications. They increased the total number of sites sampled within their state up to 50, and this included Wisconsin, Minnesota, Michigan, and Indiana. At the same time, 3 of these states also supported an ecoregional intensification that was led by the Forest Service in the Northern Lakes and Forest ecoregion, also known as the Northern Woods. The results of the Northern Lakes and Forest intensification are going to be presented by Trent Wickman at the National Atmospheric Deposition Program fall meeting this month, if any of you are planning to participate in that. So I want to bring this up to this group because there was a really rich data set collected in 2022, in addition to all the state monitoring initiatives that are done beyond for the National Aquatic Resource Survey. A lot of data were collected in the summer of 2022 associated with the NLA. And so each survey generates a number of products and resources. We do have an NLA website, but I'd like to first point people to the web report that I shared the QR code with, because this report is really a landing page for all things NLA. It links out to basically everything in this slide. The web report was written for the general public as well as water resource managers. So it's kind of a high level picture of what we do. for NLA and the results. So with that web report, we also publish a technical support document that provides details on the survey design, benchmarks, and data analyses. We also publish a dashboard for data exploration. I'm going to spend a little bit of time sharing that with you later in this talk. The survey publishes all the manuals and training videos. In fact, the 2022 training videos is the first time that they were posted on EPA's YouTube site. So these are excellent resources for states, tribes, volunteer monitoring organizations that are just wanting to jumpstart a program or expand a lake monitoring program. Although the survey is not designed to assess individual water bodies, we do have a landowner report that we can provide upon request, because we do really appreciate gaining access to private lakes and lands. This is a very concise report with results for the core indicators of the survey, and then it provides links to other resources if that individual is interested in learning more about how to interpret the data. Finally, all the data sets that support the survey are publicly available. They're published to the NARS data page, and actually there's an easier way to get our data when you use the download tool that I'll talk about in the tool section. And I also want to point out EPA's How's My Waterway. If you're not familiar with this website, it provides information from the national down to the a individual stream level of information. It's pretty phenomenal how much data and information can be obtained through How's My Waterway, and the NLA results are what's presented in How's My Waterway for the national perspective for lakes. So the probabilistic survey design allows EPA to report on the percentage of the nation's lakes in different condition categories for chemical, physical, and biological indicators. The 2022 results show us that nutrient pollution continues to be a widespread stressor, with 50% of the nation's lakes in poor condition for phosphorus. We also found high algal and cyanobacterial growth, with 49% of the lakes in poor biological condition for chlorophyll A. When viewing the chlorophyll A results with a trophic state lens, 30% of the nation's lakes were in hypereutrophic conditions. In 2022, we also saw a high frequency of detection for both atrazine and cyanotoxins, with 1 to 2% of the nation's lakes exceeding the national risk benchmarks. And I do want to point out, although it's a small percentage, this still equates to thousands of lakes. Please keep in mind the target population of 268,000 lakes. And in 2022, the fish tissue study was quite a big deal for us, since it's been 20 years since EPA has conducted a national scale study of fish contamination in the US lakes. And it also is the first time that the NLA field crews collected fish, which required a lot of additional work, partnering with their fisheries program to collect these samples. So we thank the crews for that effort. Crews targeted the collection of predator fish that were given, and were given a list of priority species that were based on the species collected in the early 2000s. So the table here shows the species and the number of samples that were collected. The most commonly collected fish was the largemouth bass, and this was true for the 2022 survey and the study in the early 2000s. Given the cost associated with these analyses, fish were collected from a subset of the lakes rather than the full 1,000 sampling events. And then the target chemicals for fish tissue analysis included mercury, the full set of 209 PCB, congeners, and PFAS. And this is the first NLA to collect any samples for PFAS, so we're pretty excited about that. So given the subset of lakes that were sampled, fish tissue results are reported for the sampled population of lakes, which is different than the full target population of lakes that we do for the other survey indicators. The sampled population is 58,747 lakes. And some of the key results I'd like to share with you now is that mercury and PCBs were detected in every fish sample collected both in 2022 and in the early 2000s. Unfortunately, mercury levels continue to be a concern. About half of the sampled lakes contained fish with mercury concentrations that exceeded EPA's recommended tissue-based water quality criterion of 300 ppb. And this really hasn't changed over the last 20 years. It was 49% of the lakes in the early 2000s that exceeded this criterion. PCB levels, on the other hand, appear to be improving, with 6% of the sampled lakes containing total PCB concentrations that exceed EPA's 12 ppb human health risk screening level. And this is compared to almost 17% that exceeded that value in the early 2000s. There is still some more work to be done on comparing the two surveys, but I just wanted to share those two preliminary results. And the survey results also allow us to explore relationships between stressors and biological conditions. So that's the goal number 2 of the program that I talked about earlier. And in 2022, poor biological condition was more likely when lakes were in poor condition with respect to nutrients and physical habitat. So this slide presents results by lake origin, those that are natural and those that might be were identified as man-made or reservoirs. And in natural lakes where phosphorus was elevated, poor biological condition is about 2 times more likely to be poor, which is suggested by the relative risk results here. In reservoirs, poor biological condition is 2.8 times more likely when riparian vegetation cover is poor, just showing the connection of riparian habitat and the quality of littoral benthic communities. But one of the most common comments we get from the program is, yeah, the national perspective is great, but what about my state, my region, or my area of interest? And so when preparing this talk, I wanted to know how many lakes have we sampled in the MGLP service area and what could be done with the data that have been collected over the years. And so I want to thank my colleague, Morgan Mack, that helped me out with this work. She joined the MGLP service area at Shapefile with the NLA sites to identify the lakes that have been sampled as part of the NLA, and then ran condition estimates for your service area. But before we went into that, we needed to see how many lakes were in our data set. The number of probability lakes ranges from 239 to 247, which is really great. So at the regional level, we aim to have at least 100 sites to generate condition estimates with a reasonable amount of certainty on that point estimate. We've also sampled 57 hand-selected sites, and for the survey years 2007 to 17, these were all sites that were identified as being possible reference sites. It doesn't mean that they are reference sites, but that's a pretty good, a solid set of reference lakes to be sampled in your area as well. But I also want you to keep in mind that we aim to revisit 10% of the lakes as well. So many of these have more than one sampling event. But when you look at it holistically, there are 753 lakes that have been sampled unique lakes that have been sampled over the years. 165 of these have been sampled in more than 2 surveys. And there's only one lucky lake that has been sampled all 4 years in the NLA. But I want to note that this high number of lakes sampled within the MGLP service area is not only because of the high density of lakes, but also because the states of Wisconsin, Minnesota, Michigan, and Indiana have elected to conduct intensifications for nearly every survey. So it's fantastic that they've contributed to this rich data set. And then this is just a map of the 2022 probabilistic sites that were sampled within your service area with the 4 NARS ecoregions and lake origin. So that is if the water body was identified as a natural lake, which are the circles, or the man-made lakes, which are the diamonds. So Morgan was able to use these 235 sites to generate population estimates for the MGLP service area. And with that exercise, we estimated around 50,450 lakes. I did see that the MGLP website described the service area as 80,000 lakes. So there's a little bit of a difference here in how we, I think, define the different target populations, but I thought these values were close enough to run the data through our tools and kind of see what it would tell us. So I'm going to share a series of slides here with results for the MGLP subpopulation with the national results. And to get started, I want to kind of coach you on how to read these slides. The bars present condition estimates as the percentage of lakes. And when viewing the slides, I want you to first look at the top, the MGLP results, with the width of the confidence intervals, and then view that same condition category in the national results, which are in the bar charts below. And the first two indicators we're starting with are measures of lake productivity. So trophic state on the left, which we determine with the nationally consistent benchmarks, versus chlorophyll A condition on the right. That's based on an ecoregional benchmark or expectation. And so for trophic state, we're seeing around 3% of the MGLP lakes in a oligotrophic condition, as compared to 7% at the national level. Looking at hypereutrophic, we're seeing 24% versus 30%. So I don't believe these differences to be statistically significant given the confidence intervals. But to compare that to expected conditions within your service area, we're seeing around 32% of the lakes being in good condition with respect to chlorophyll. So that is that they are within so the good condition benchmark is set at the 75th percentile of reference. But once again, I just want to point out that what we're seeing here is really similar to what we're seeing at the national level. Moving on to biological condition, showing both the results for the benthic macroinvertebrate and zooplankton indicators. We're seeing good biological condition ranging from 50 to 43% of the MGLP lakes, which is once again pretty similar to what we're seeing at the national level. Nutrients around 41%. The two nutrient indicators being total nitrogen and phosphorus, we're seeing 41 to 32% of the MGLP lakes in good condition. Slightly higher amounts of pore with respect to phosphorus, but this is also consistent with what we're seeing at the national level. When we do start to see greater differences in condition categories when we're looking at the physical habitat indicators. So this slide is presenting drawdown with small, medium, and large categories, and then habitat complexity. And the MGLP lakes overall have a greater percentage of lakes in good condition categories with fewer lakes in poor, which is great news. Definitely some good shoreline and habitat management happening in your area. And then the other two physical habitat indicators include our lake shore disturbance and then riparian vegetation cover. Once again, slightly greater percentage of lakes in that good condition category when compared to the national results. And then finally, I had to include a slide on recreational use, knowing that some people might be owners that live on a lakeshore property. And these two are looking at microcystins and enterococcus, where the majority of the nation's lakes are at or below these two human health risk thresholds, with enterococcus, which is a fecal contamination indicator, having a slightly higher percentage of lakes at 7% of the lakes, both within your service area and nationally, being at risk for recreational use. So ultimately, what I think this exercise convinced me is that comparing the results from your program to the national results is that the national results are really relevant to your service area. And this might be because there are 4 different ecoregions represented in the surface area. And maybe the ecoregional results would be of greater interest depending on where the lake is located within your service area. And we do start to see some deviations from the national condition estimates at the ecoregional level. And this can be explored through our data dashboard. I'm just sharing two screenshots here. They're examples of how you can view the data in the dashboard. So the upper right is trophic state in the temperate plains ecoregion, and the lower left is the upper Midwest ecoregion. The blue and red bars on the left-hand side of the figure, so right here, are displaying the point estimates with confidence intervals for that ecoregion. And then there's like this gray band or a box that represents the upper and lower confidence intervals for the national results. So here you can see a greater percentage of hypereutrophic lakes in the temperate plains compared to the national results, as well as a greater percentage of mesotrophic lakes in the upper Midwest when compared to the national point estimate. And so this is when I would like to show you a demo of our data dashboard. Well, this is the dashboard, but let me go to the report really quick. I'm going to go to the top and grab this. So I mentioned that our report is a great place for like a landing page of all things NLA. You can easily navigate to the data dashboard here and then open it up. And so the default view when opening our dashboard is good condition for the national results. To see all condition categories for an individual indicator, there's these little gray bar charts next to the indicator name. And if you click on that, it will pop open and it will give you the good, fair, and poor condition categories for the population that's selected. And we're on the national view right now. I'm going to close that. And hovering over each of the indicators will give you a brief description of the indicators, so you have a better understanding of what you're looking at. In fact, you can hover over a lot of different pieces of the dashboard and it gives you additional information on that particular result. So right now, we're viewing the data with the point estimate displayed in the figure, but you can also change that view so that there are no numbers. So it's just like a cleaner representation of it. Or you could do the confidence interval range as well, if that's of greater interest to you, but I'm just going to go back to the point estimate. So now I'm going to flip over to the right-hand side of the view, and this is where we present results on change. The user has the option to select two different time periods that are being presented in the graph. So right now we have 17 to 22. You can also view 2012 to 22 for the study population. And it will vary for which one that is selected here under study population. And I want to point that this is showing you the change as percentage points, and that any bolded diamond is showing you a statistically significant change. All right, and so now I want you to look at the middle of the board, which is titled trend, with the three different columns here. And when you hover over these charts, you will see the pop-up here will contain the estimates for all survey years available, as well as the linear regression results. So those are all the results in this initial landing page. Now I'm going to show you how you can change the data that are displayed. Right now we're looking at the all lake population, which are those that are greater than 1 hectare. You can also look at, I'm sorry, we're going to go back to, I have it on the wrong change period here, so let's change that. The larger lake study populations, those are lakes that are greater than 4 hectares, which will pull in our 2007 results into the dashboard. The 2007 study only focused on that larger lake target population. So that gives you 4 points here in trend. You could also change the category that you're looking at. Maybe you're not as interested in good, but what is poor? What are the stressors that are seen within a given area, and you also have the option to select different subpopulations. So you can compare results by natural versus reservoir. The three NARS ecoregions. You can also select the NARS 9 ecoregions. So I'm going to go to the upper Midwest right now. And when you do that, notice that there will be a map change above the dashboard, and it kind of shows you what area of the country you're actually looking at. So let me go to temperate plains. It will show you where the data that are represented for that, or where that is within the continental US. So I'm going to go back to all lakes here. And then finally, one other thing I want to point out is that maybe you're interested in not seeing all the indicators for a given population, but maybe comparing a subpopulation or comparing the different subpopulations. So here I'm going to, we're looking at trophic state for poor condition, which is representative of hyper-eutrophic conditions. And I'm going to select maybe the 9 NARS ecoregions, and we can see how variable hyper-eutrophic conditions are in the different NARS, the 9 ecoregions, as well as our confidence in those estimates. And there's something really interesting going on in the xeric ecoregion, and it's related to some high weights for some lakes there, but kind of low confidence in that particular result this year. All right. And since I have this on trophic state, I do want to point out that the only trophic state that we identified as either good or fair or poor was hypereutrophic, given that oligotrophic, mesotrophic, and eutrophic conditions could be natural, and depending on where you are within the nation. And so you kind of have to open up that full view to see all of the trophic state results in the dashboard. All right, finally, last thing I want to demo here is, and I won't spend much time, but that the risk estimate results, let me kind of reset actually this here, and I'm going to go to risk, can also be viewed for different subpopulations for both benthic macroinvertebrates and zooplankton, and these subpopulations as well. So that is our data dashboard. Let me go back to my slides. And I just want to emphasize really quickly that the dashboard is meant to be a data exploration tool. We want to share as much information as we know about our data and results with our partners. But there are a few things we want users to be aware of as you look, especially at the trend and change results. So the first thing is that trend results are limited by the number of survey years that are on the board. So for the all lake population, that N is 3. For the large lake study population, the N is 4. I mean, at a minimum, we'd like to see 20 years or 4 survey cycles of the survey represented in any trend analysis. And that's before we start to pull these results into our national reporting. And then second, there have been some changes in the sampling frame over the years. These changes were necessary to improve the target population estimates, and this has increased the total number of lakes that we have characterized in the target population. And this has primarily been the number of small lakes in the target population as we've gotten better precision in the sampling frame. So as EPA has been exploring the trend results, a number of new research questions have surfaced for us. We're looking into a lot of those right now, and we encourage all of our partners to do the same, to ask what additional data analyses should be considered where data are suggesting a significant trend. And so this resulted in some new dashboard text. If you happen to read that, that's the reasoning behind that. All right, so I'm going to wrap up this talk with a brief overview of some tools that I think could be of interest to this group. I'm going to start with our data download tool. We have a really rich data set that might be of interest to the MGLP partners out there. The old way of getting NARS data is that you had to download Excel files individual Excel files, individual metadata files from our website. We now have a download tool that allows you to explore the data sets using drop-down menus. And then you can also join join site-specific information when downloading the data, filter it to a state of interest. It's just a lot easier to get the information that you need in a couple steps versus doing post-filtering after you download the large files. And I'm also excited to share that we just recently added fish tissue data to the tool. Prior to this, users had to navigate to OST's website for the fish tissue results. Now you can find everything in one place for a given survey. Another tool that might be of interest is our lake context tool. It allows lake managers or a citizen science organization to compare data collected from their lake to the state, ecoregional, and national results by survey year. It was originally built with only chlorophyll A, total nitrogen, phosphorus, and sake. We expanded that parameter list with the 2022 results. And we're also, the ecoregional aspect is also new in 2022. The output from this tool is a box and whisker plot. These boxes represent the 25th. So let's look here, the 25th, 50th, and 75th percentile. The whisker is the 5th and 95th percentile within that particular either state, region, or nationally. And then the blue line here represents, the horizontal line represents the user input. And so here it's just an example that chlorophyll A of 10 micrograms per liter is within the 74th percentile in a lake in Michigan. In 2022, the 50th percentile in the upper Midwest. This is how it compares to the temperate plains, and then nationally, it's within the 36th percentile. So you can download a little report like this from this tool. Next, if there's anyone that's interested in designing your own probabilistic survey, we have a tool that can help you with that as well. It's called our survey design tool. It utilizes functions found within the R package SP survey. It presents an easy to use user interface for many sampling design features, stratifications, unequal and proportional inclusion probabilities. There's a lot of different options depending on how you would like to design your survey. The output also provides design weights that can be used in categorical and continuous variables. So this slide is showing where you can link to the app on the NARS website. However, I should note that I've heard that it works much faster when running the app locally. So I also provided the GitHub information as well if you'd like to download it and run it locally. And then when data are available for analysis, we have a tool for that too. It's the population estimates tool. It's a shiny app that allows for calculation of population estimates as it's performed for the National Aquatic Resource Surveys. It also provides visualization of those results. This was the tool that was used to generate the midsection with the MGLP subpopulation results in this talk. Super user-friendly and easy to generate results using this tool. It calculates, once again, either categorical results or continuous results that would be visualized as a CDF. And then I'm gonna wrap up this talk with kind of what's next for our program. We are a reoccurring survey, so we're constantly, once we wrap up an individual survey, we almost immediately go into planning mode. We're pretty lucky this time that we are able to get the report out in just 2 years for NLA, so we have a year of planning. One thing we're really focusing on right now this fall is updating our dissolved oxygen indicator. We've received a lot of feedback on that in external peer reviews. And so we're hoping to make some progress there and have an updated indicator for the next round of NLA. And then in 2025, in the spring of 2025, we're going to reach out to all of the NLA partners including our states, tribes, our ORD and OST partners for new research indicator proposals. Summer is going to be really focused on the National Coastal Condition Assessment field season. So a lot of NARS team members are going to be focusing on that. Then we'll transition into fall and winter, and the NLA survey design should be completed at that time. And that's what's going to inform us on the funding needs. So in spring of 2026, we'll put out a call for state and tribal participation so that 106 funding can be put into place to support field work and participation in 2027. Also in 26, I want to share that we have our National Wetland condition assessment happening at that time. So I'm sure there'll be a lot of activity in your states as well during that time. All right. And in 2027, we do all of our training in spring, and the field season starts in June. And just want to give a big thank you again to all the NLA partners that make this project possible. It's truly a team effort. We could not do it without you. And so now I can take questions.
Thank you, Lareina. Really, really valuable stuff, and I really enjoyed going through all of the breadth of what the NLA has to offer there, and seeing the MGLP specific summaries was pretty neat as well. So I'll remind folks, if you have questions for Lareina, please enter them into the Q&A function, and you can do that again by taking your mouse, hovering it down over the bottom of the screen. There's a Q&A button. Click on that, and you can submit your question. So our first two questions, I believe, are a success story of your presentation. I'm going to share them with you, and you can speak on them if you'd like. So the first question was, do you have a slide or information on the fish tissue results from the service atlas? And then later, another person asked, who I assume was the same person. Never mind. They said, never mind, I used the NARS data tool to find the info on the fish tissue I was looking for. Thanks for going over the tool. So it sounds like they found what they were looking for, but I wanted to give you the opportunity to talk more about the fish tissue results and where folks might find them.
Yeah, I think that was a big advancement there. It was kind of hard to connect. Since it's funded by a different EPA program, we've kind of independently managed those data sets. And so through the data download tool, you're now able to, we don't have the lake names, but you can go through and add in information about what you're looking for, filter by your state, and it's a lot easier to digest and find what you need compared to kind of how you would access the data in the past. So I'm glad you found what you were looking for, and please feel free to reach out to me if you have any questions about either the data or the tool. But then I also have another contact on here, John Healy. He's our partner with our Office of Science and Technology that leads a lot of all the fish tissue work that we do for the National Aquatic Resource Survey. So feel free to reach out to him as well if you have questions about how to interpret some of the results.
All right. I do not see any. Oh, we've just got another one that came in. We've had quite a few landowners request their data once it's available. Is it possible to get that landowner package you mentioned at the beginning of your talk for all of our sites, or is that more meant for one-offs?
We are definitely happy to work with field crews that, yes, I mean, that is, but it is upon request. And so I feel free to email me. I will work with our ORD partner, Karen Blossom, has written code to auto-generate these reports. They're about 2 to 3 pages long. They're very simple. But yes, please reach out to me if you have a site ID list. It sounds like you are an NLA partner that might have the NLA ID available to them. And if you happen to, I know you wouldn't have the unique IDs. Well, if you have our site info file, you would have the unique ID as well. And then Karen can easily generate those reports.
Thank you. All right. I do not at this point see any additional questions from folks online. So now's the point where I get to ask questions. So I'm curious about the PFAS results in particular, and I guess sort of just wondering how those have been received. I know that's a very hot topic these days. So curious how those have been received, if you've seen actions being taken as a result of the NLA PFAS sampling, just more
Um,
broadly.
that's a tricky question to answer. I guess the best way for me to look at that, let me see if I can get back to that slide really quick. Um, we are presenting the results in a different way because we're showing the detections, right? So these are the PFAS, the 8 PFAS parameters that were detected at least 15% of the lakes. And right now, I think our messaging is that there are some PFAS parameters that are detected in nearly everywhere, or they're detected everywhere in places where we wouldn't necessarily expect them. But we don't want to be in the position. EPA is not in a position to be able to speak to consumption advisories. We need to work with our state partners on having an understanding of what's present in their states and those individual water bodies, and being able to communicate that at more at the state and lake level. So I think this is pointing that it's something that we all need to be looking at. It's present and it's ubiquitous in a lot of the nation's lakes. But now it's like, okay, what are we going to do at the state and the local level to understand what the actual risk is and then communicate that to the public?
Thanks. That's a great answer, unfortunately, for a tough situation that our lakes
Mm-hmm.
face. Okay, we are nearing the top of the hour, and so I'm gonna put out one last call. If folks have any additional questions, now's your opportunity to submit those questions. Um, And while we're doing that, one of the pieces that you mentioned was that you guys are looking at potential new dissolved oxygen indicators. And so I'm kind of curious if you would be willing to speak to why you guys are looking at that, what the reason for the potential update would be, and if there's a climate change context to that conversation.
We are exploring all of that. So and maybe to take a step back, I can explain to you how we currently assess dissolved oxygen, and that will probably shed light on why we're looking to improve. So back when the indicator was how we determined we were going to assess DO back in, I don't know, when NLA started, early 2000s, we went with a really simple approach, and it seems to work pretty well. They're averaging the top 2 meters of DO regardless of the lake depth. And we're only doing a surface water assessment. And I think we all know that surface water only tells us part of the story about what's happening with dissolved oxygen in lakes, and it might not necessarily be very representative of fish habitat and suitability for a range of aquatic life, especially since the crews are there in the middle of either the morning or the day, wherein dissolved oxygen might be at some of its highest concentrations. And so it is just a single visit. We're not doing 24-hour profiling or anything along those lines for the NLA, but I think we can do a lot more with the data that we have. So we're aiming to assess the full profile right now, instead of just only looking at the surface water. And also characterizing, I think it's still to be determined if there is going to be a climate change component to it. But one of the ways we're thinking about it, and I don't want to, I don't know what, we still have some decisions to be made, but looking at the percentage of lakes that have the potential to support cold water fisheries. And is that changing over time? The percentage of lakes that stratify and go anoxic. So we sample a lot of shallow, small lakes in NLA. So there is a large portion of our target population that does not stratify over the index period, or it mixes on a more regular basis. And so we're trying to characterize that as well. And so I think those are kind of questions that might be of greater value than to the broader lake management community than necessarily like the top 2 meters and whether or not it meets the 5 and 3 milligrams per liter DO thresholds that are associated with our 304A criteria.
Thank you. And yeah, I think there's been a fair amount of research, some of which has been done by collaborators with the MGLP that's looked at within the MGLP area that shows pretty concerning patterns as relates to dissolved oxygen in cold water habitats. So I think it's a great advancement that you guys are looking at that and looking at considering how to capture that moving forward. We do have one last question. This will be our last question. With the change in site selection of lake size compared to the past years, was that factored into any analyses? If so, were any trends uncovered?
Oh boy, that is like that is yeah, that's a big question. So what I can speak to, and that's one of the things that we're actually taking a pretty deep dive into right now, is how smaller lakes are influencing the national perspective. We've had a greater number of smaller lakes sampled over the years, but what we have seen is that it's not consistent. Um, Across all ecoregions. There are some ecoregions where the change in the number of lakes is dramatically different than others. So I'm just gonna put it out there. It's coastal plains. Coastal plains is there the polygon the number of lakes that are within the target population has changed quite a bit. It's a little more stable in every other ecoregion. And so we're trying to get a better understanding of what's happening in the coastal plains. Are we really seeing a change in the number of lakes that are present there, possibly due to development, creation of new stormwater ponds, climate changes? Or is it really a change from going from NHD plus to NHD high res? And so we're working through a lot of those questions right now. But I mean, I can't really speak to it in a lot of detail, but we are hoping to kind of tease apart, are some of the trends that we're seeing, is it a small lake trend that we're seeing? Because I know that the response time that the response time in larger water bodies is greater than what we're seeing in smaller lakes. And so yeah, we've got a few. We want the size piece is definitely going to be part of the discussion as we roll out 2027 results, and we're starting to kind of tease that apart right now.
That makes
Mhm.
sense. All right. Well, thank you. You've gotten through the lightning round of questions. Really appreciate again. Wanted to say thank you for giving the webinar today and sharing this information with the MGLP audience. So for the attendees that are on with us still, this concludes our webinar. I encourage you to check out our webinar next week. We have Julia Kirkwood and Jen Buchanan speaking on the basics of shoreline erosion control, and they're going to be sharing some new documents to help in design and management of shoreline erosion control. So germane to this audience. Um, and again, a recording of this webinar will be posted and put up on our website as well as on our YouTube channel. So if you want to share it with colleagues or watch it again, you're welcome to do so using that link, and you should see that email in your inbox notifying you of that posting in a week or so. So again, thank you, Lareina, and to everyone else, thank you for attending. Have a good day.
Thank you for having me.
Gladly.